In this lecture, I want to present a case study of some of the concepts we've been studying in this course. In particular, the ideas of scope and functions and how those work in closures. We're going to do this in JavaScript, which is a dynamically typed language, unlike Scala, which is mostly statically typed. It also has first-class functions and objects like Scala. It is designed to run in browsers, and of course that's why JavaScript is a language you've heard of. It runs in every browser, including the one I'm using right now. Programmers that started doing client-side code in web browsers really like JavaScript, and as a result, it was implemented server-side as well. So you can actually implement your web server in JavaScript now using Node.js. It's inspired by functional languages and object-oriented languages. The functional model is very similar to what we have in Scheme. It's a traditional dynamically typed functional language. The object language is unusual. We'll look at that in a separate lecture. It's based on the idea of a delegation-based inheritance, which is different from what you're familiar with in a class-based language. When JavaScript was created, there was no standard for scripting in web pages. Sun had just spent a lot of marketing energy trying to say that Java would be the right way to do it. And that's why the developers at Mozilla decided to call their scripting language JavaScript, because it sounded like Java, which was getting a lot of buzz at the time. The language has nothing to do with Java at all. JavaScript eventually won the contest to see what language would dominate the web, and it was standardized and has the relatively awful name ECMAScript. ECMA is a standards body that I believe only does this. It just publishes JavaScript standards. They're updated very regularly now. Every year or so you'll find a new standard. If you want to go look for documentation on JavaScript, I suggest you go to Mozilla. They have by far the best sort of online reference to the language. The last time JavaScript got a version number was around 2015 when ES6 was released. Since then, it's been considered a living standard. You can see here a table of compatibility in various web browsers for features of the language. You'll see here that most ES6 features are widely supported. There's some exceptions, however. For example, the proper tail call optimization is supported just by Apple's browsers at the moment. This is, of course, the optimization that allows us to take a recursive call and convert it into a loop. It's interesting to note that this is part of the JavaScript standard and should eventually be supported by all browsers. JavaScript was created in a frenzy by Brendan Eich in the mid-90s, and it wasn't a perfect language when it was created. Some of the bad parts have been fixed over time, and we'll talk about some of those changes today. If you want books on JavaScript, it's interesting to look at this free series, You Don't Know JS. If you look at the titles in this series, you'll see several things that look familiar, in particular scope and closures, this and object prototypes, which we'll talk about today, and asynchronous computation. Axel Roschmeyer has also written some very accessible material on JavaScript. The nice thing about JavaScript is that it's built right into your browser, so if you want to play around with it, you can just go to the developer JavaScript console in whatever web browser you're in, and you can just start typing stuff in, like what's 1 plus 2 or 1 plus 3, and it'll just give you an answer. You can also use Node.js. You can type expressions directly into the JavaScript console. You can also access the console programmatically from other JavaScript resources executing on a web page. If you use the console.log function directly within the console itself, you'll see that it's going to print out the result of whatever expression you're logging, but it also prints an undefined message. What it's showing here is the result of the console.log call itself. When I call console.log, it has a result which is undefined. Undefined is something like void in C-like languages. We can also define functions, of course. So if we have a function like f here, we can just type that into the console. And you can see that declarations give a result which is undefined. And we can then use the result that we've defined to call the function. Syntactically, JavaScript has both statements and expressions, and thus it requires the use of return inside of a function to give the return value. We can have side-effecting functions here. In this case, the function is making a call to log something on the console, which you can see here. But the real goal of JavaScript is not simply for console input and output. It's to work over web pages. Web pages are represented in programs using what's called a document object model, or DOM. The DOM is the object representation of an HTML page, at least initially. Your web browser renders this document object model. It doesn't render HTML directly. Instead, HTML pages are read into an object model, which then can change over time. And the web browser shows this document object model. JavaScript was created in order to cause dynamic changes to this document object model. JavaScript was designed primarily to provide interactivity for web pages, and therefore the primary mechanism it uses is event handling. The idea is that when you write a web page, you can have buttons and things, users can click on those, and those will cause code to get executed. Let me show you a simple example. Here's an HTML file that I've loaded into my web browser. Note that I've got three things on the screen. One is an input box, currently with value empty, and the other one is a paragraph, hi mom, a paragraph, hi dad. I've given these things IDs, A, B, and C, so that I can refer to them from JavaScript. So I've got a file here called skeleton.js. And if I look in that file, you see I can find these elements, A, B, and C, from the HTML document, and then refer to those objects in my code. For example, I can set the value of A to be 1 plus 2, and I can set the HTML of C, that was hi dad, to have extra stuff on it. So this is going to append to the HTML of that paragraph. So if I save this file and reload the page, you get extra stuff. So note that the value of A has changed, and in addition, I've extended my document by appending onto the last paragraph. I've also registered a listener here. So I've got a listener for on-click working on B and C. So that means anytime I type on B or C, I will execute this function. Here, let me try it. I'm going to click on B here. And when I click on B, I get this extra stuff. So what has it done? It's taken the target, in this case, that would be B, and it has said, oh, I'm going to add again on there. I've also got a counter, so note that my count initially is 0. If I click again on hi mom, I'll get it again. If I click again, I'll get it again. So note that these are coming right after hi mom, so I'm just appending after hi mom. I can do the same thing for hi dad and get these. If I click on other elements of this document, you'll see that I can get the same effect. Whatever I click on, that's what's going to get appended to. That's the target of this click. In your web browser, you have the ability to right-click and inspect an element. This will show you what the document actually looks like dynamically. And you can see here that all of these paragraphs I'm clicking are getting added within the div B or C upon which I've attached this listener. And so if I click here on the 0 again, you'll see that it's just adding it in. You can see from this that the target of the event I receive may be a sub-element of the DOM element upon which I registered the listener. So B and C are where the listeners are registered, and that means that the target may be anywhere within those elements. In addition to working at the command line, you can also work within a playground such as JSBin, and you can see that this works more or less the same way. There are many playgrounds you can work in, but to get started, it's sufficient to just download this HTML and JavaScript files into the same directory on your local host and fire up the HTML, edit the JavaScript, and reload. See what happens. JavaScript has some very odd behaviors that are the subject of derision, and you can find a really funny talk here describing some of them. I'll walk through them in a bit more sober fashion. The source of a lot of confusion in JavaScript has to do with its very, very complicated system of conversions. JavaScript was designed to be as forgiving as possible to amateur programmers. The idea was that who knows who's going to be programming the web, and we don't want to reject their programs with fiddly compilers like Java did. So we'll just kind of take anything and try to make sense of it. As a result, though, there's some bizarre behaviors. So square bracket plus square bracket is the empty string, whereas square bracket plus curly bracket is object. Curly bracket plus square bracket is 0. And curly bracket plus curly bracket is not a number. So part of this has to do with bizarre conversions. The other part has to do with the overloading of curly brackets, which mean both the empty object and also a block or an expression. It's not really important that you understand why these things happen, but it's interesting to know that they do. Other surprising effects happen because of the interplay of dynamic types and optional arguments. For example, if I have a list here of 3 tens and I map the parseInt function across it, you might expect to get 3 tens. But that's not what you get. You get 10, not a number, and 2. And the reason here has to do with some optional arguments of parseInt and how it deals with these things. In addition, you might note that there are perhaps surprising defaults. Here, if I sort the array 1, 5, 20, 10, I end up with 1, 10, 25, which may not be what I was expecting. The reason here is that sort by default sorts strings. JavaScript coerces all the numbers to strings and then does a string sort on them. JavaScript also has both undefined and not a number, which can become confusing. Undefined plus 1, for example, is not a number. Coercions also happen with the equality operator, and this can create terrible outcomes. For example, the empty string is considered inequivalent to the string with a 0, but 0 is equivalent to the empty string, and 0 is also equivalent to the string with 0. This makes no sense, but it's just the fact of conversions and how they're happening here. False is not equal to false, but false is equal to the string 0. False is not equal undefined. False is not equal to null, but null is equal to undefined. In addition, you have white space always equal to 0. So these things are quite odd. And the sensible thing to do in JavaScript is simply to avoid the double equals operator, which does this kind of conversion, and use the triple equal operator, which does not do these conversions. So it has more predictable results. Take a second and look at this program to see what you think it's going to do. And all of this kind of makes sense. When I look at my main program, if I print A, it's 1. And then again, 1. So A doesn't change. That's my global A. Thus, this assignment on line 5 is to a local variable. Note that that's in a little block, so I might expect that that variable assignment is local. So I might expect this on line 4 to print 1. But what I get is actually undefined. Well, what's going on here? JavaScript hoists or moves variable declarations up to the top of the nearest enclosing function, but it does not move the initialization code. That means that this that I've written is equivalent to this other program where the declaration of A has been hoisted. JavaScript does initialize all variables, but it initializes them to undefined, and that's why this program prints what it does. To get proper block scope, you use the let operation that was introduced in ES6. This has the effect you expect, which is that the reference on line 4 is actually to the global variable A. Let bound variables are block scoped. They don't move up to the top of the enclosing function, but the top of the enclosing block. And blocks here are denoted with curly braces, so this little declaration of A is contained. Variable declarations get hoisted regardless of how deep they are in the syntax. So this declaration on line 5 is going to get hoisted up to the declaration of F. And note that it's in a conditional. It doesn't matter whether the conditional is executed. This is a syntactic operation. So this declaration is going up. And that means that this assignment on line 3 is always going to be a local assignment. It's never going to change this global variable declared on line 1. And you can see that my main program is always printing 1 for A. And that happens regardless of whether the block that declares A gets executed or not. As I said at the beginning of the lecture, functions and objects are first class in JavaScript. And just to remind you, that means that we can create these at runtime, we can pass them around, we can return them as results from methods, we can store them in variables and data structures, etc. And nested functions in JavaScript are very, very common. JavaScript uses lexical scoping. You can find an article about that at Mozilla here. Just like Java inner classes and lambdas, these nested functions are common in callbacks for graphical user interfaces, for handling asynchronous calls, and for doing collections processing like map and reduce. Unlike Java, JavaScript uses only a single thread. That's great because it means that the model is really simple. The problem here is that if you have any infinite loops in your JavaScript code, you'll lock up the entire JavaScript engine. If that's JavaScript interpreted by a web page, the browser is going to completely lock up. You might say, how is this possible? The web browser has to respond to user input. It has to respond to activity on the internet. How can it possibly be single-threaded? Well, in fact, browsers are multi-threaded, just like Node.js is multi-threaded. And most of the work actually happens in those APIs. JavaScript is really intended just to glue together the results of work happening in various web APIs. Recently, JavaScript has gotten actual multi-threading using the APIs for web workers and WebAssembly. But we'll concentrate on asynchronous programming. A typical JavaScript program is going to register a bunch of callbacks on the web API of the browser when it starts up, and then it's going to sit there and wait to be called back. Whenever we actually do get a callback into the JavaScript, we'll handle that, potentially registering new callbacks onto the web API. This kind of asynchronous programming can get quite complicated. Let's think about just a simple example. Let's say we're trying to do predictive typing for Wikipedia entries. Predictive typing looks like this. As I type letters, I get potential results, which I can either click on or continue going. So if you think about how this is implemented, it's not trivial. What I need to do is register a listener for the keyboard strokes. If a key is pressed on the keyboard, I need to parse the input and send off a request to Wikipedia for the possible completions. And now we're going to have two things potentially coming next, either another keystroke or the response from Wikipedia. And as keystrokes come in, we're not interested in the old response from Wikipedia. We need to make sure we're always getting the newest ones. And that kind of programming can get very complex. Whenever we receive a keystroke, we initiate an HTTP request. And whenever we receive an HTTP response, we want to show the completions. But these can happen in any order. There are design patterns to help make this kind of coding easier. For example, the reactive extensions developed by Microsoft and the Redux patterns used by Facebook. We can use callbacks in processing collections as well using map, filter, reduce, and friends. These are all built into modern JavaScript. So JavaScript has higher order functions and it has mutable state. I wonder what it does with unpleasant combinations of those things. Recall that Java disallows the use of a mutable local variable inside of a nested class or lambda. In order to code this example, we're forced to make a copy of the mutable variable, which is effectively final. It never is mutated within the block of its declaration. JavaScript is a permissive language, and therefore it's going to allow code along these lines, but it's not going to give us the result we want. It's actually going to do something very akin to what happens in Python and Perl. As I said, JavaScript is a single-threaded language, so I can't use exactly this example. Instead, I'm going to create an array of functions and simply call all of the functions in the array. If I do it, I'm going to get this output. And this is very similar to what happened to us in Perl, where I had a variable I. I'm going to loop on that variable I here, creating a closure for each value of I, or so I think, and that would be 0, 1, 2, 3, 4. The final value of I is 5. And therefore, when I invoke all of the functions, what I get is always 5. The problem here is that I'm closing on the variable I, not the value of I. Of course, we wouldn't expect to fix this with a shared variable x, where we're simply copying I into x, because x here is obviously shared, just like I. But if we move the variable declaration into the block, we might expect it to work, but it doesn't. Note I get a different result. I get all 4s. And why is that happening? Well, now we're only looking at the values that I actually has and associating those with x. The final value of x is going to be 4, not 5. Why is this happening? Hoisting. In order to stop this, we need a proper block scoped variable, as in ES6. And when we do that, we actually get the result we wanted. Now, this is possible in ES6. What did people do before 2016? Well, they had to do something fairly dreadful. And in fact, it's so common it has a name. It's an IFI, or an immediately invoked function expression. What does this mean? I declare a function here. This is an anonymous function, or a lambda in JavaScript notation. My function body is going to have the code that I want in my block scope. And the function here is an expression that is immediately invoked. So this is an immediately invoked function expression. This is a bizarre thing that you would not see in any other language. Why is it here? It's here just to give me a scope for the variable x. And if I do have this scope, then I get the result I expected. This is such a dreadful idiom, though, that it's quite nice we don't have to use it anymore. Of course, I did that with an anonymous function. You could also use an explicitly named function. Here I've done that by taking the anonymous function and saving it in a variable. You could also just write function help is x, does the same thing. And then here in the push operation, I'm actually going to invoke this separate function here that has a copy of x. Note that what's being pushed here into the funcs array is a closure, and that closure has the value associated for x at the point of call and the function which is being returned. So I'm returning a function here which returns x. So funcs is an array of functions, and what I'm pushing here is the result of the call to help, which is itself a function. So you can see that very clearly in the syntax where I'm using the direct lambda notation as the literal to be pushed. So this is a function literal which returns x. Here instead I'm using a function factory. So help here is a function factory. That is a function that creates functions. Note the syntax. I return a function that does something. Functions returning functions. How familiar. JavaScript is an interpreted language, so in order to extend the language, you just need to provide a library. That library is just a text file full of JavaScript that gets loaded by a browser. One library that was hugely successful early on is jQuery. jQuery became ubiquitous in web browsers, so much so that I think people thought that the $ was actually a built-in part of JavaScript and not part of the library. jQuery provides a single function called $. The $ function provides lots of interesting new functionality, but it also provides a lot of functionality that's already in JavaScript. It's just that the early browser implementations of JavaScript were so inconsistent that it was very difficult to use. jQuery provided a wrapper which dealt with a lot of these inconsistencies. So this would allow the programmer to program to the jQuery standard instead of trying to figure out how the vendors were implementing JavaScript. Now that JavaScript has become more standardized, jQuery is just not as important. Another early library is underscore. It has a companion called Lodash. These both define a single object named underscore, and this underscore has lots and lots of functions in it, such as map, reduce, etc. And these as well are less important now that these functions are built into modern versions of JavaScript. There are JavaScript libraries that are still important that add non-trivial features and extensions. Two of these are TypeScript and Flow. These add types to the language and allow errors to be checked early on by a compiler. Angular, Vue, and React all add a component system for describing web pages in pieces. Babel is particularly interesting. This is a JavaScript library that provides an interpreter for JavaScript. This allows older browsers to use new JavaScript features even though those aren't actually supported by the browser vendor themselves. There's also JavaScript extensions that allow assembly code to be executed in the web browser. These are used for taking old C programs and running them on the web. There's also a lot of JavaScript code intended just for developers. npm allows you to find new bits of software and easily download them onto your machine. Webpack allows you to package everything up in a way that a client can run efficiently. We've just scratched the surface of JavaScript. It's a fascinating language, and we'll look in a later lecture at its object-oriented features. But if you find JavaScript development intriguing, you might consider taking our Web Applications course, that's CSE 436.